please make sure you've done these ahead of time, or at least do them as I do them. Like if you haven't done this yet, work on it, see what you get, then play it, press pause, try the next one, play it, press pause, try the next one. All right, please, you're really hurting yourself, some of you guys. I know you're not doing that, and you're really hurting yourselves for this test. Some of you that are getting these 16s and 30s on these tests, I'm telling you, really, really do a better job studying. This is one way to do it. All right, write the polynomial function in terms of linear factors. I got to factor this out. Now, if they gave me one solution even, I could do synthetic division on this, but they didn't. So it's going to be up to me to be able to factor this. Or you could look at the graph. You could take a look at your graph. You could put this in y equals, look at the graph, and look for solutions. That's one way to do it. So write that down. You could use the graph to get some solutions, which then you could get factors. But this is factorable by grouping. If you just split the middle there, you get x squared times x minus 2. And, oh boy, 2x squared minus 12x plus 24. Okay, so x squared times x minus 2, and then negative 12 times x minus 2 is what you should get. So common binomial is x minus 2, and then x squared minus 12. Now, so you know x minus 2 is going to be a factor, so it's not going to be b. It's one of these. Now, x squared minus 12 does not factor nicely. It is not x minus 3x plus 3. Okay, I mean x minus 4x plus 3. You should know that it's not that. It's going to be something here. Don't think like, oh, it's got to be I. It's got to be I. No, not necessarily. To get the factors, set it equal to 0. And then add the 12. X squared equals 12. Take the square root. Now look at x is plus minus radical 12. It's not negative under the radical. So this is going to be 2 radical 3 plus minus. So it's just plus minus 2 radical 3 there when you simplify it. So that's going to be x plus 2 radical 3 and x minus 2 radical 3 along with your x minus 2, because obviously we have that right there. So just be careful, guys. Make sure you're solve the equation out equal to 0. Find the solutions, then go back to the factors. All right, so we're going to raise first here. 5 to the third. 5 to the third, and then x to the multiply. So negative 12 there. All right, so that's going to be times 4x to the fifth. This is 125 x to the negative 12 times 4x to the fifth. And then 125 times 4, of course, is 500. And then negative 12 and 5, you got to add those, so you get negative 8. 500x to the negative 7th. There we go. 500x to the negative 7. All right. Rewrite the expression in kxn form. So we got to get rid of the radical, basically. Now, it's a cubic root. 3 is the root. So it's 8, the cubic root of 8, 8 to the 1/3. I'll leave that one as a radical because I can do that. I can do that part. Now, x is to the 6 over 3. Remember, guys, power over root. 6 is the power, 3 is the root. Y to the 7/3. That root is the bottom of the fraction when you have an exponent. Okay, so 6 over 3 is 2. This is 2. Cubic root of 8 is 2. So this equals 2x squared y to the 7/3. Choice C. This one's just definition, 7, and then square root. Bottom number is the root. So 6x to the 7th and the square root. So that's going to be this guy right here. The 6 is on the outside. The 6 is not raised to the 7/2. See, the 6 is not raised. So the 6 is on the outside of the radical. Only the x is getting raised. This one I got to put in log form. Where's my base? Log base 5 of the amount equals the exponent. Log base amount equals exponent. Log base 5 of x equals 3.71. Choice D. All right, so for number 6, make sure you know about even, odd, and neither. Okay, so even, just going to write it here. Even is symmetrical to the y-axis, and odd would be symmetrical to the origin. Symmetrical to the origin. All right, so just remember that as a side note. So if you graph these with your graphing calculator, I'll just kind of show you what they look like so that you can get an idea what I'm talking about. This one does go right through the origin. Does this. Again, you need your graphing calculator to actually see it for yourself. But it does something like this. Okay, well, that kind of messed that up. But you could see it here. Whereas if you draw that exactly the way I did, and then flip your paper upside down, or you'd flip your calculator upside down, and you would see it does the exact same, looks the exact same. It goes right through the origin. So this is an odd function here. This one is just the sine function shifted up 1. So that's got a midline of 1. All right, so you're going up like that. And now this one, it does not flip over the y-axis. It's not symmetrical to the y-axis. And if you flip your calculator upside down, see how it intersects at 0, 1? If you flip it upside down, it intersects at 0, -1. So this one does not, this one's neither. It's not even or odd. So this one's neither. And then this one is going to be the even one. Okay, it's up at 4. All right, and it's, cosine function, where it does the same thing on both sides. So you flip it on the y-axis, you fold it right on the y-axis there, and it lands on itself. I just sketched it. I didn't draw it great, but that is an even function there. This one we got some work to do. So 6 minus 3i times 6 minus 3i, that's got to be done first. Remember, guys, you can't just square these individually. It's 6 minus 3i times 6 minus 3i. And then that'll come along for the ride for now. I'm going to do these first because it'll be just a little easier to do it that way. So I'm going to get, this is going to give me 36 minus 18i minus another 18i, and then plus 9i squared. Plus 9i squared. So that's going to be 36, and then I squared's -1. Let me just write this out. 36 is going to be minus 36i, and then 9 times -1 is -9. 36 minus 9 is 27. So 27 minus 36i. And that gets multiplied by 2 plus 5i. And that comes out to be 54 plus 135i minus 72i minus 180i squared. That's plus 180. So it ends. This is plus 180 after you do the I squared. So it ends up being 234 plus 63i. 234 plus 63i. That's pretty ugly. Okay. Add 71. That's 125. Divide by 8. This is the step that all you guys were forgetting earlier. A lot of you were forgetting to do that step before you raise it. So x to the 3/4 equals 125 over 8. And then just raise to the reciprocal. Raise it to the reciprocal, which is 4/3. And that makes that a 1. See? Raise both sides to the 4/3. And x is going to equal 625 over 16. Simplify each expression so it's a KXN form. All right, so we'll do the top first. 20x to the 4/3 over, now this has to be done here, 2x squared. That's 2 squared is 4, and then x squared. See what I did there? 2 squared and 4x squared. It's a monomial, so you do square them both. 20 over 4 is 5. And then here, you have to subtract the exponents. 4/3 minus 2. That's calculator work. That'll be x to the negative 2/3. Again, where did I get that from? I got it from my calculator. I did 4/3 minus 2. And that gave me negative 2/3. So there's my answer. Everything gets squared. 6 squared is 36. X to the, well, I got to multiply. When I raise to a power, I multiply. Negative 5 times 2 is negative 10 over 3. And that's it. 36 times 36x to the negative 10/3 is all you can do there. That's KXN form. All right, here I have a 1 outside here, so it's 1/5. 1/5. And then here I have x to the, let's do it this way. X to the 3/4. That's what this means. And this is x to the 4/3. So I have to subtract those. I have to do 3/4 minus 4/3. 3/4 minus 4/3. In my calculator, that gave me negative 7/12. So I have 1/5 x to the negative 7/12. All right, there we go. Scientific notation. Take this to a 13. We've done a bunch of these. You guys are good at these. 0.393 times 10 to the 13th minus 5.8 times 10 to the 13th. So the only thing different here is you're going to have a negative. So 0.393 times, or minus 5.8 is negative 5.407, which is okay. Negative 5.407 times 10 to the 13th. Solve for x. So what we're going to do here is divide the 12 out, first of all. So I get 1.45 x minus 1. And that's going to equal 32. Now let's use our change of base formula. You could do it with change of base. So it'll be log base 1.45 of 32 equals x minus 1. This is log 32 over log 1.45. Again, change of base. And that's going to be 9.3274. That's good enough. Equals x minus 1. So then you have to add 1 to get it to be x. And that's going to be 10. So x is going to be 10.3274. That's good enough. All right, moving on, page 3. We have average rate of change over the interval. So we're going to do f of 4 minus f of 2 over 4 minus 2. Now, I did these ahead of time to save time. You could put this in your calculator, the y equals, or you could plug in 4 and plug in 2. All right, plug in 4, plug in 2. You get 768.867 something minus 151.8 something 75 over 4 minus 2. So that's going to be 616.99218 over 2, which is approximately 308.496, roughly. Okay, I rounded it to the nearest thousandth, but you would round to whatever they tell you to round to unless they don't specify. An exponential equation, get the common base. Here I have 5 to the x squared minus 4 power. This is going to be 5 to the negative 3. 1 over 125 is 5 to the negative 3. We have to know that. We have to know that. 1 over is negative, and then 5 to the third is 125. Okay, so 5 to the negative 3 is x. You could guess and check with your calculator if you can't get it. All right, so this is going to be 5 to the x squared minus 4 equals 5 to the negative 3x. Now I have my common base. So I'm going to set my exponents equal to each other. X squared minus 4 equals negative 3x. X squared plus 3x minus 4 equals 0. Factor. Negative 4 and 1. Okay? All right, so for number 14 here, in central Maine, an acre of land is currently valued at $3,200. Experts predict that land in Maine will increase in value by 2.75% per year. Write an exponential function to model the growth. All right, so we're going to write our exponential function, assuming exponential growth. And that, I know this part here is a little different than what yours looks like. The assuming exponential growth part is actually in your part A, okay? But this, I didn't copy it onto here correctly, but it's the same. It's asking the same question. So we're going to use our function, right? Our exponential function. A equals a sub 0 e to the k t minus t0 plus b0. Okay, which we rarely use. All right, so A equals, the amount we start with is 3,200, and then we're going to have e to the 0.0275, and then that's the rate, right? So 0.0275 t, because we don't know the time. All right, now, assuming exponential growth, how much will an acre of land be worth in 5 years? So that's just putting in the time, right? 5 for time. All right, so 3,200 e to the 0.0275 times, double parentheses, times 5. All right, make sure you got the parentheses in there correctly. And that is $3,671.69. So that's that one there. Now, all right, evaluate this expression. We're getting there. So this, we're going to do this first. You have to square it first. So it's going to be, I'm going to go over here, it's going to be 4 times 10 to the negative 5, and then 7 times 10 to the, 7 squared, so 49 times 10 to the 8th. You have to multiply the exponents there. Okay, so now that's over 2 times 10 to the 7th. Now you got to do the top first, multiplication. That's going to give me 196 times 10 to the 3rd. Hopefully it gave you that. Divided by 2 times 10 to the 7th. That's going to be 98 times 10 to the negative 4. And then I know we can't leave 98. We have to make it 9.8. Moving to the left, we're going to move to the right. So 9.8 times 10 to the negative 3. Yep. Write a 4th degree polynomial function with roots 4, negative 3, and 5i in factored form. That's easy. F of x equals x minus 4, x plus 3, and then x minus 5i. But you can't just have x minus 5i. You must also have x plus 5i. Remember, those complex roots or imaginary roots, they come in pairs, conjugate pairs. So there we go, 4th degree. There's the last one right there, x plus 5i. So that's done. Now how about standard form? Standard form is all about multiplying this out. So multiply these. You get x squared minus x minus 12. That's what you're going to get for these two. This one gives you x squared minus plus 25. Give you x squared plus 25 because it's minus 5i squared. Minus 5i squared is plus 25. Minus 25i squared is plus 25. All right, now you do a 3 by 2 table, and so you should do that. I want to see that on your paper. I want you to do that now. Draw that out, and I want you to make sure you fill it in. I'm going to see if you don't have this filled in, if you don't have this done, I'm not going to give you full credit. We'll see if you're paying attention to this video or not. I want to see you fill in this table and see what you get. You should get, I'm just trying to save time on your video, you should get x to the 4th minus x to the 3rd plus 13x squared minus 25x minus 300. If I did it right. So f of x equals, that's going to be standard form for the polynomial. I want you to fill this in, see what you... All right, last one. The Acme Company in Walla Walla, Washington has developed a new cell phone case that can withstand extreme pressures. They decided to put this case through a rigorous test. At the beginning of the test, the case is placed in an environment where the temperature is 70 degrees Celsius. That's the beginning. That's going to be the y-axis. 5 minutes later, it's cooled to 30 degrees Celsius, negative 30 Celsius, and then 5 minutes later, it increases to 70 again. The pattern continues for 30 minutes. Create a graph from 0 to 30 and determine the equation of the sinusoidal function that models the test. So for 30 minutes, it's every 5 minutes, right? 5 minutes up, 5 minutes down, or 5 minutes down, 5 minutes up. We start at 70. So we're going to go by tens here. 10, 20, 30. I'm going to actually just decrease this a little bit. 30, 40, 50, 60, 70, negative 10, negative 20, negative 30. Good enough. We start at 70. 5 minutes later, so we can go, we only got to go to 30, so we'll go 5, 10, 15, 20, 25, 30. Now, if you did yours by fives, that's fine. I know we only got to go to a total of 30 minutes, so that's all I did. I did by fives every 2 boxes. I did 5, but it's whatever you want. So this is minutes. And, of course, this is your temperature in Celsius. Temperature in Celsius. Okay, so we start at 70. 5 minutes later, it's negative 30. So at 5, you're going to be at negative 30. 5 minutes later, it's back to 70. 5 minutes later, negative 30. 5 minutes later. How do I know it's doing that? Because it's a sinusoidal function. Sinusoidal means it's doing the same thing over and over again. So whatever it did the first 5 minutes and the next 5 minutes, it continues that pattern. 25 will be negative 30, and then 30 is back to 70 degrees. So what's our midline? So we can plot some midline points. Well, in between 70 and negative 30, just add them up. Well, 70 plus negative 30 and divide by 2. That's going to be 20. So 20 is going to be our midline. And as you can tell, that is right in the middle. In between 0 and 5, obviously, is 2.5. In between 5 and 10. So in between a max and a min, guys, it's going to hit your midline. And there it goes. So just make sure, and this is hard to do on this thing I'm writing on, but you know what it's supposed to look like. Curve it as much as you possibly can. Oh boy, I knew that was going to mess up. This thing I'm drawing on is like impossible. So I could go through and try to fix that a little bit, but you guys know what it's supposed to look like, I think. Please make sure yours looks better than mine before you turn this in. Okay. It should go here, and then it should go start curving again. Should be more like that. So, all right. So hopefully you, again, yours looks a little bit better than mine does. Okay. All right, you guys got the idea. I don't want to keep messing with you here. All right, and determine the equation. So we need f of, let's do T of x. We'll call it T of x for temperature. T of x equals, well, the amplitude is the midline up. So from 20 to 70 is 50, right? From 20 to 70 is 50. It's cosine because it starts at the max. So 50 cos. I mean, by now we've done a lot of these guys. You need W, which is 2 pi over the period. Now the period is one full cycle. So it goes from here to here. So it takes 10 minutes to make a full cycle. The period is 10. 2 pi over 10 would be your W, which is pi over 5. Okay, so pi over 5 x. And then the midline is 20, so plus 20. All right, amplitude 50, period is 10, which gives you a W of pi over 5. Insert that in the function, and then plus 20 for your midline. All right, see you for the quiz tomorrow.